because we're sort of the last line of defense. So we need to find the bugs that are there.
Stephan is a test pilot at Airbus. And today we're going to get some really interesting insights into his career, his daily business. What is the maximum amount of Gs you were able to
The maximum
fly?
I've seen on an aircraft was 9.76. That was on a Typhoon, and actually it was a limit exceedance because it's supposed to be limiting the G load to a maximum of 9.0.
How did it feel when you first set into a fighter jet?
It was incredible. It was. I mean, I've been dreaming about it. Basically, one of the prouder moments in my life when I got my wings pinned on by my dad, who used to be an Airforce pilot himself.
You never fly with the integrated weapons in it.
Actually, we do carry the weapons that are being integrated, but those are then not live weapons. It's all about attitude. It's about your own attitude, how you approach what you want. Whatever it may be, it won't be there for free.
Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour.
Hello everyone and welcome back to a new episode of On Air Actually Rocket Science. I'm Gigi.
And I'm Florian.
And we are today's hosts. On this podcast, which is organized by the Student Council of Aerospace and Geodesy, we usually interview the professors from our department. But today we have a very special guest. Please welcome Stephan Leuthner.
Hi.
Thank you so much for joining us today.
Thanks for having me.
So for those who are unaware, Stephan is a test pilot at Airbus. And today we're going to get some really interesting insights into his career, his daily business, some of the technologies he's working on, and a lot more. So sit back, relax, and enjoy. But before we start, I actually have one question for you because you just came from work.
Yeah.
So did you fly a fighter today?
Yes, actually I did. I flew old school Tornado today.
That's amazing. That's amazing. All right.
Yeah, that's so cool. And since we are already on the topic of flight and fighters, we wanted to know about your daily basis. What is your daily routine? How does a day look like? Because we can imagine, I mean, you said you flew today, but do you fly every day?
No, unfortunately not. And I mean, that's a good thing in betting. There's nothing like a real daily routine for me. So as a test pilot, the flying is only about maybe 30% of my job. So there are those standard days where we fly, like today. The day usually starts when I get to work. I already have my test cards. I know what the test will be on that day. And I'll go check the weather, check the NOTAM, so notice to airmen if there's anything in the airspace. I'll get together with my team, the flight test engineers, the weapon system officer if it's in a Tornado. Then we'll have a briefing together, which is usually an hour and a half. Then we have some more preparation for the flight, file the flight plan, get the weather checks, do a briefing in the crew and all that. And then there's the flight and afterwards the debriefing. So on a standard day, flying-wise, actually the whole day is basically taken up with flying preparation, the flight itself and the debriefing. As I said, on the other days, it's really a mixed bag. So it can be that I'm in a simulator doing certification work. It might be that I'm meeting up with engineers doing some design development stuff, or I'll act as a subject matter experts, or anything else that comes along. So it's really the interesting part of the job is to work with all kinds of engineers, with all parties involved in aircraft design and development, where I can sort of try to get my few couple of words in there and maybe get some achievements done, which is interesting then.
Yeah, that's so cool. And the main goal of testing an aircraft and to evaluate the performance and if its problems, if it has any, how exactly does the procedure look like? You just told us to work with the engineers, talk to them, but is it more about collecting specific data from sensors, or is it more based off your feeling, or if you can say it like this?
Well, it depends on what the aim and the objectives of a flight test campaign is. For example, flight today, it was mainly in regards to a new weapon that needs to be integrated and the avionics system of the aircraft, if it works properly. So you get together with the engineers beforehand, way before the test, design the flight test program, and it really covers the changes in the software, and you try to figure out test procedures to measure the software's performance and figure out if there's any flaws or faults in it. And a good test flight usually is a test flight where you find issues with the software, because we're sort of the last line of defense, so we need to find the bugs that are there. For other flights, like for example, if you do a integration of a new store, if you do a change to the flight control system, to the control laws, that's what we call handling quality assessments. That's actually what you meant with, hey, how does the aircraft feel? But it's not like I'm getting in there and say, yeah, this feels good. I like it. There's specified tests on the quantitative side and the qualitative side. Quantitative meaning we have defined test procedures where we basically gather data, aerodynamic data, flutter data, vibration, acoustics from all kinds of sensors, which allow us to do a very objective view into the aircraft stability and control. Now, on the other hand, the qualitative side, the side, how does it feel? Basically, the apparent stability and control to the pilot. That's being assessed mainly by handling quality rating tasks. It means you define a specific task that is important for the aircraft you're testing. For example, in a tornado, you do a task where you need to do an air-to-surface attack. And then you fulfill that task, and it's designed in a way such that you can give a rating afterwards. And that rating basically transfers your subjective opinion of the aircraft into an objective rating that is reproducible by any other pilot. And it's interesting. And yes, every once in a while I can say, hey, this really felt funny. I don't know why. And then we look into the data, look into flight control system, see if any issues arose. But it's really dedicated test procedures that we're using. So any other test pilot could go there, fly the same aircraft, fly the same test, and get a similar result. And that's the important thing about it.
Okay. And you talk a lot about like the actual testing you're doing, but I can imagine you also have to train because you have to be fit for being a fighter pilot or flying a fighter jet. Mm-hmm. So is it like, how does your training look? Do you have a lot of physical training or a lot of training on the simulator, like you already talked about?
Well, the physical side is basically up to each individual. And I'm not the youngest person anymore. So with increasing age, I realized that I have to increase my physical fitness training as well. So when I was younger, I was like, yeah, whatever, I'll just do it. Now it's like, yeah, I do some running, I do some rowing. We got a horse stable back home, so I do a lot of shoveling shit, which is actually a really good physical exercise. And on the other side, simulator training, yeah, we have to fulfill the same qualification requirements as any Air Force pilot, for example. So there's the minimum hours that are required. There's specific dedicated emergency procedure training. Every month we have to fill in a bold phase sheet, we call it. So bold phases are immediate action items from the checklist that you have to know by heart. For example, your engine fails, you have to know immediately how to react to that. That's what we call the bold phase. And we test that every month. And then we do check flights annually. And so a lot of training has to be done in the background before you do the flight testing.
And actually, coming back to the weapons you talked about, like you obviously also have to test the weapon since you're basically the last step of the chain. Where exactly do you test weapons?
Well, when we talk about weapon testing, for me, it's the integration into the avionics system. Okay. So I do not fire the weapons, if you will, mainly because I'm a civilian flying military aircraft, but still a civilian. So the end-to-end test where the actual weapons are being launched is conducted by the air forces, who are the customers. What we do is test the integration of a weapon system into the whole aircraft. So back in the old days, you'd have a gun and the gun would fire, and there's no real integration. Nowadays, you have a variety of ordnance that can be used by an aircraft, which is deeply integrated into all the aircraft systems. So that means whenever you have a new weapon or a change to a weapon system, you need to verify that all the interfaces are working properly, that the exchange of information that is required between the aircraft and the weapon works properly, and that if in the end a pilot would trigger a missile, for example, then all the requirements are fulfilled to allow the missile to work as designed.
So basically, whenever you are testing a new, let's say, design of an aircraft, you never fly with the integrated weapons in it?
Actually, we do carry the weapons that are being integrated, but those are then not live weapons, so they will not have a warhead in them, or they will not have a rocket motor, for example. But because those weapons usually have a lot of software and computers within themselves, so we need to have those testing devices, usually instrumented, so they also produce flight test data. And it's the weapon, but it couldn't be launched or couldn't be used.
Oh, that makes sense. And you also mentioned that you're a civilian now, and in fact, your career at Airbus started a while ago. In fact, you've been working there for 12 years now.
Yep.
And you start your career as experimental test pilot and project pilot of the Typhoon. And then for the past 3 years, you were employed as project pilot for the FCAS and GF and for the Typhoon. So my question would be, what exactly is the difference between a project pilot and an experimental test pilot?
So the experimental test pilot is the qualification. So, going through test pilot school, doing that 1 year's course there and achieving that qualification, it's part of my license as well. That's just what an experimental test pilot is. In my role as the project pilot for the Typhoon, there's a couple of test pilots at Airbus in Manching, for example. But in my role as project pilot, anything that comes into Airbus related to Typhoon and needs, for example, a signature or a verification, validation, it goes across my tests. So basically, of the test pilots in Manching, I'm the one responsible for anything that goes on with Typhoon. The others fly it as well, but I'm the first point of contact, if you will.
Okay, and on that note, because the Typhoon was basically put into operations in 2003.
Yeah.
And why exactly is it still required to have test or project pilots for projects that are basically already in operations? Do you have that for every aircraft which is in use?
Yeah. It's like, as I said, Typhoon went in service in 2003. It had its first flight in 1994, so 30 years ago. Tornado that I flew today, also on a integration test, had its first flight in 74. It's 50 years old. But still, also, the airframe itself is very old. The software and the computers within the aircraft are constantly being evolved and developed. You need to basically keep up with developments in the weapons sector on the opponent side as well. So you constantly upgrade your aircraft. And that's what we're doing. It's developmental flight test, if you will.
Okay, makes sense. And you're wearing your pilot suit today. And I also see you have a small pet there. So is there any fun story behind that?
Yeah, that's GRISU. So, usually those military pilots, they have like call signs, nicknames. We call them call signs. My call sign is GRISU. Now, a couple of years ago, I think we had a visitor's day in Manching. I told people, hey, I'm GRISU, and people were looking at me, younger generations, like, what is a GRISU? It's like, okay, that's when I bought the little guy there. So GRISU is a cartoon from the late 70s, 80s, I think, about a little dragon who wants to become a firefighter. His dad hates him for it, and dragons can't be firefighters, but he wants to be a firefighter. Unfortunately, he keeps lighting shit up all the day and, burns stuff down. In the end, he saves the day all the time, but it's, that's what GRISU is. And that's why I have him with me, because no one of your generation knows GRISU anymore. So this is GRISU.
But did you choose this name because you're a bit of a troublemaker like him? Or
no, you don't choose your nickname or your call sign. Actually, once you arrive in a fighter squadron after your training and you start working there, flying there, at some point in your career, you'll screw something up or do something funny or something specific. And then the squadron gets together and they decide upon your call sign. And so your call sign is being awarded to you, and there's no way to reject it. So that's the call sign you're getting from the squadron, and for me, that was GRISU.
And is there any specific reason why you got this name? Or?
Well, usually those stories can only be told at a squadron bar with a lot of beer. But let's say, there was a party involved with my mates, and maybe some drinking, and maybe there were some fire extinguishers, and maybe some guys who didn't want to join and didn't lock their rooms. And let's not go into more detail than that.
Okay, fair enough. And on the note of the pilot suit, it's a typical thing for pilots to wear those, but is there any specific reason why you have to wear them, or just...
I think that the pilot suits, those overalls, I think they came up in basically in the beginning of the flying days when the officers, they wore their uniform and they took those overalls to wear it over the uniform, not to get any grease or anything on their good clothes. And later on, nowadays, we have those flight suits as our standard, part of our standard equipment. It's a flame retardant material, so I don't think it would help a lot, but at least, it makes you quite it's flame retardant. And it's really comfortable as well. So,
is it?
Oh, absolutely. And I mean, the only choice I have to do in the morning is I'm going to wear a white t-shirt or a black t-shirt under it. So it makes life a lot easier.
Yeah, for sure.
And you will never see me in a suit and tie. So it's one of the things I do not wear.
Okay, like you already told us, you flew a Tornado today, but you already flew the Tornado at the Airforce for 14 years you were there. And right after you joined the Airforce, how did your training look like then?
So when I joined the Airforce, I joined it as a standard officer's candidate. And you do standard military training. The officer school, that's about 1 year. So basic training and then 9 months of officer school. Thereafter, I went to the Armed Forces University in Munich, in Neubiberg, and did my degree in aeronautical engineering there. So back then it was still a diplom engineer, sort of, similar to a master's degree now. And thereafter, I went through my flying training. And the flying training starts off with lots of academics and theoretical training, English training, and whatever it is. Then you move on to single-engine propeller aircraft, where you do your first assessments, where they tell you, hey, you're good enough or you're not. It's called the screening. And then if you pass that screening, you basically go through the United States training there. It's called NJET, Urinator Joint Jet Pilot Training in Shepherd Air Force Base in Texas, where you have about one and a quarter year. Back then, I started on a jet trainer, the Cessna T-37. It's a side-by-side jet trainer, very nice old aircraft. It's called the Tweet because it's got a very high-pitched whistling noise when you start up the engines. It's interesting. And then you move on to a supersonic trainer, the T-38, where you do your first supersonic flying. It's a high-performance aircraft, difficult to fly, but a good trainer. And thereafter, you get a quick introduction to fighter fundamentals, they call it, also on the T-38, where you do your first dogfight maneuvers and your first air-to-surface maneuvering. And that's about a year and a quarter. After that, you receive your pilot's wings. So it's basically one of the prouder moments in my life when I got my wings pinned on by my dad, who used to be an Air Force pilot himself. And he actually flew the same aircraft in Shepherd that I flew, which is a funny story on its own. Same tail numbers. And with your wings, then you move on to whatever weapon system had been assigned to you. For me, it was the Tornado. So I moved to Alamogordo, New Mexico, where the German Air Force back then had their training base. And it's about another year of weapon system training. And that basically then means that you are able to fly and operate the aircraft. But the real training starts afterwards in the squadrons, where you get your basic combat training. Basically, it's a taktische Erstausbildung, it's called. So it's initial tactical training, where they teach you how to operate the Tornado as a weapon system within a squadron with other aircraft against other aircraft. So it's a constant training, basically, and you never stop learning.
How did it feel when you first set into a fighter jet? Well, can you describe it? Or
it was incredible. It was. I mean, I've been dreaming about it my whole life. I was like, I've seen my dad fly, so he flew Starfighters and Tornadoes, and we went to the airbase where he operated from a lot as kids already. There were family days and the squadron, and at around Christmas, Saint Nicholas came to the squadron and things like that. So I've been watching that all my childhood, and it was always like those planes, and it was cool. And then I was 6 years old. I had my first flight in a motor glider, not with my dad, funnily enough, but with friends of ours. And he took me along, and when we took off, I told him, but don't do any steep turns and anything. I was really scared.
At 6?
Yeah.
Years old?
Yeah, but I was just a passenger, I was just sitting next to the guy.
Crazy.
And I got out of the aircraft and said, I'm going to be a pilot. And I knew then I'm going to be a pilot. And I never had a plan B. Fortunately, it worked out because I wouldn't have known what to do apart from that. So I never learned anything properly apart from being a pilot. And then, so that was one of those moments. And then actually the first time I sat in a Tornado, you do a lot of, before you do your first flight, you do simulator training, a lot of academics. But I remember sitting in there was like, oh, it's really happening. It's like, oh, I can't believe it. I'm doing this. And it was great.
But so the first time you sit in a fighter, basically, you've obviously, like, all of the training you do happens in a simulator? Or is there also the possibility to basically sit with someone else inside?
No, on the Tornado, it was like on most legacy fighters, it's really like you do a lot of preparation in the simulators, especially it starts with system handling, how to start up the aircraft, how to operate all the systems, check that on the ground. Then you do a lot of emergency procedure training. So you basically go through all possible emergencies in the simulator, and they want to see that you can handle those emergencies on the ground in the simulator before they send you flying. And then the first couple of flights you fly with an instructor pilot, and he'll be in the back seat. So there's special trainer aircraft for the Tornado that have a stick already installed in the back seat. And you'll have an instructor pilot there with you, and he'll guide you. And if something went terribly wrong, he'd just take over aircraft control. But once you start flying after the simulator, you're actually at a point where you can handle the aircraft. It's nice, yeah. Then you have your first crew solo, obviously, where you don't fly with an instructor pilot, but one of your mates, your classmates, who's a weapons system officer. So the first time you go off on your own, it's like, yes.
What is actually more scary? Like, sit in it for the first time with the trainer, or your solo?
No, that was all. It was never scary. I think the only time where it was like, holy shit, is my actual first solo flight. So the first time I flew alone on a T-37, where you take off with your instructor pilot. And it's only, I think it's 7 or 8 flights, and the 9th flight is a solo flight. And so you go flying with your instructor pilot, and you do 3 traffic patterns, so 3 touch and goes. He just, checks you out again, that your landings are good. And he gets out of the aircraft and sits in a little tower there next to the runway to, keep watching you, and sends you off on your own. And you go airborne, and suddenly you hear strange noises that weren't there before. And you're like, okay, does that always look like this? Is this instrument always in? It's really, that first flight, you're hyper alerted to anything that's going on around you. But coming back, it's the feeling it's incredible, especially if you've dreamed about it all your life. Then, finally being allowed to fly on your own, it was nice. It was really good.
Imagine that. Yeah.
And afterwards, you take a bath in a very, very cold pool. It's also a tradition. So all your classmates will throw you into the cold water with the flight suit. So, but it's part of the game. There's lots of little traditions like that are part of the whole experience, basically.
Do you still have your flight suit from back then?
Yes, actually, I still have it. I even fit in it. So yeah, I kept my first flight suit.
But you aren't allowed to wear it at Airbus.
No, I wouldn't, because it's I might be allowed to do it, but it's something I just keep for memories. The flight suit, the helmet, I still have that back home. Yeah,
makes sense. So for the training, I can imagine the G-force you have to pull in such a fighter jet are quite high. Do you have like a G-force trainer like at NASA, where they spin around?
The centrifuge, yeah. You have to do that in your initial training. So it's a part of the qualification process as well. They check you out in the centrifuge, and the initial training, they actually put you in there without any G protection suit. They just want to measure your natural G tolerance. And, somewhere around 6-7 Gs, it gets really exhausting, and you just have to try to keep awake. And then if you fly the Typhoons, you have to do regular centrifuge training, refresher training, just to prove that you're still able to withstand the G-forces, and to get a refresher on the breathing techniques that you have to use. So yeah, that's what we do on a regular basis, every 3 years there. You
just mentioned the G-force protection suits. Do you wear them when you fly the jet?
Yes.
Because like you said, you wear this suit.
I wear that under the other stuff. That's what I had actually planned on bringing along today, but because I flew in the afternoon, now the guys, the maintainers, have to check my equipment for my flight tomorrow. So I couldn't bring it. And the other helmet that I could have brought is a bit too expensive. Yeah, but usually you wear a anti-G trousers and a vest. In the Tornado, only the trousers protect you from the G forces because it's not operating at that high G loads. In the Typhoon, actually, the vest and the pants, they will inflate when you will pull on the stick and increase your G forces. The reason being, once they inflate, they put some pressure on your legs and on your stomach and on your chest, to help you keep the blood flowing to your legs. And you need to strain your muscles. You get the pressure from the outside, and that prevents the blood going into your legs and you going unconscious, basically, if you will. And because with the Typhoon, where you have the higher G loads, the vest is also inflating to get pressure from the outside, because your helmet will give you pressurized breathing, just to, stabilize your system as well. And you don't notice it when you fly. So it's there, the anti-G protection is there, but it's not a conscious thing noticing it anymore.
But wouldn't it add like additional pressure onto you because you have the acceleration and also the active pressure of the vest?
But the acceleration basically is just downwards. It's NZ, if you will. And the pressure is from the suit is on your body. And basically what it does, it cramps together the arteries in your legs, just to prevent the blood from going south.
All right, yeah.
We can imagine testing new aircraft is kind of a risk. Is there a risk you see in testing the new aircrafts? I mean, you talked about like testing a lot of software, but do you actually test a new aircraft that's being developed by?
Yeah, we're doing both. So I've also one of the first programs actually I flew in when I got to Manching from test pilot school was a modification of the Typhoon. They changed the aerodynamic shape of the aircraft with leading edge tensions, increased size flaperons, changed flight control laws, allowing a lot higher angle of attack during maneuvering, which basically means now you operate the aircraft way outside the envelope that it's been cleared for. And yeah, theoretically, there's the risk involved that you don't know what the aircraft might be doing. But nowadays, there's a lot of preparation going into it. It starts off with wind tunnel testing, with theoretical analysis, goes with computed fluid dynamics in specific areas, up to a point when you do the flight test, you have a very conservative test program. So you don't go, let's go, this is the edge of the envelope, let's go there immediately. But you approach it stepwise, very slowly. And it's always a team effort. So every flight you'll have a bunch of system engineers and specialists who will be monitoring what you're doing via telemetry. And whenever they see something that goes out of the ordinary, we call stop and say, okay, let's hold it here. Let's analyze what's been happening and then continue in this flight, or come back home, analyze on the ground, and then decide how to carry on. So the risk is really minimized in regards to that you're flying a new aircraft.
So we were actually talking about G's training and all of that. So one of the questions I have is, when you start training to basically sustain the G's, you said you use this like centrifugal test bench. How does that exactly work? Do you start right away with, 7 Gs, or is it more of a gradual?
I would say they have specific profiles that you have to fulfill, where, first it's a stepped approach to go to a lower G force to see how you're doing on that day, something like 4 or 5 Gs. Then it's a gradual one to a higher G load. You maintain it for a bit longer. And towards the end, you'll do a snatch pull, basically, where you have the controls yourself, and you can get the maximum acceleration, which is, I think, 12 Gs per second, up to the 9 Gs, and then you maintain those for a couple of seconds. The whole training is really there to, well, first of all, test your G tolerance, but also you want to start slowly, and you do that in flight as well. So whenever we fly, we do a G warm-up maneuver, we call it. So you do 2 turns at 4G and 5G, just to get your body going and get a feel for how good you are on that day. Because there's days where your G tolerance is way up there and nothing can harm you. And there's other days where you have to work really hard. And once you go beyond the 7 or 8 in the centrifuge, or also in the aircraft, it actually is really exhausting. It's a lot of work for the body.
And do you get nauseous after doing this testing, or is it?
Actually, in the fuge, yes, every once in a while. The bad thing is when it stops. So because you're turning in circles, it really is just the Z force that's being excited for your body. But when the fuge slows down, it feels like you're tumbling forward, and it's really horrible. And there's lots of guys who felt very sick or even puked after the centrifuge. They have their paper bags in there as well, just in the aircraft. Yeah. But it's really not the centrifugal motion. It's the stopping where you feel like you're tumbling forwards.
And so
in the aircraft, we try not to get sick. It works most of the time.
Has it happened?
Oh yes, yeah. Well, for example, when you're doing aerodynamic data gathering for the aircraft, you have maneuvers we call roller coaster, which involve a lot of pulling and pushing. You push -3G, you pull +9G, you push -3G and do an inverted roll while you do that. And you do that for 45 minutes, and at some point you start being sick. You can't prevent it. Or I don't know too many who can. But it's not a bad thing. When you notice that your body is sort of starting to feel the effects, and you just say, hey, I need a little break. You take 2 or 3 minutes of level flight, and then it's usually good again, and then you start over.
And let's say, technically speaking, if you get sick on flight, what happens?
Well, that's the other good thing. If it would happen, it hasn't happened to me.
Okay.
I never got this far. If it would happen, I mean, it's a good thing to have that overall,
Really?
Well, it sounds funny. Whenever I take along a passenger, I brief some passengers, I tell them, wer kotzt, der putzt. So whoever pukes has to clean the aircraft. It sounds funny, but it helps people remembering that they need to use their bags. The reason being, if you throw up in the aircraft and you throw up over the harness of the ejection seat, puke is acid, or it's a lot of acid in the puke. Yeah. And actually, if it gets over the harness, they have to take out the seat. They have to check the harnesses if the structural integrity of the material is still given. So puking in the cockpit is something you really want to prevent, not only because it's embarrassing, but also it might damage your equipment.
Fair enough. And still on the topic of Gs, so you mentioned that the training goes obviously between 1 and you said 12 Gs for
No,
1 second.
it's 9G, but the acceleration is 12G per second.
And what is the maximum amount of Gs you were able to
The maximum I've seen on an aircraft was 9.76.
Yeah.
That was on a Typhoon, and actually it was a limit exceedance because it's supposed to be limiting the G load to a maximum of 9.0. So on that day, a lot of different factors led to overshooting the maximum NZ. So 9.76 is my personal record.
And I mean, I know it's probably difficult to explain, but how does that feel like? Because I can just not imagine how such a force would.
Well, I mean, you've ridden roller coasters, obviously, I guess, and you know that feeling when you go through a looping that really it presses you into the seat. You get heavy. You get the feeling that you can't really raise your arms properly. And it's the same just with magnitude of 2 or 3. You feel very heavy. It feels like it presses you. It compresses you. You start to have to breathe strongly against that pressure. And it's a breathing technique that helps you keeping conscious. And it's just like everything weighs a lot. It's difficult to raise your arms. It's difficult to keep your helmet straight. Mm-hmm. So you got somewhere between 1.5 and 2 kilogram helmet on your head that becomes excessively heavy then in that case. And it just feels like someone is trying to compress you. It's you get used to it. And as I said, where maybe if you're not used to it, 4 or 5G, you feel very uncomfortable. For us, it's really like, okay, you don't notice it, but anything beyond 7 starts being exhausting.
Okay.
Even for trained pilots. So.
And let's say the difficulty when you have to sustain Gs is it the breathing or what makes you basically faint? I mean, if you faint, what is it?
Well, the fainting is because due to the G forces, basically the blood in your body will also be forced downwards in the direction of the G. So that's what that suit and your breathing technique try to prevent, to get the blood or to stop the blood from moving downwards. And you can feel it actually if you're losing that battle. Your vision starts to tunnel in. The vision starts to gray out a little bit. And that's the point where either you have to relax the G or you have to really get one more strain in there and try to open that tunnel again. And that's what you try to prevent, or that's what you feel. And it's basically, it's just physically exhausting. So if you do a flight where you have a lot of high G maneuvers, afterwards, it's like after very, very intense physical training.
Okay. I think in one of the questions you also mentioned that during your training in the military, you also do your first supersonic flight, if I'm not mistaken. Yeah. How did that feel like?
It's absolutely unspectacular.
Really?
It's really just that needle moving over the 1.0 and that's it. Yeah, I was the same. I was like, yeah, supersonic today. And it's basically, it's just a number on the digits. Yes, you see a little bit of, depending on the aircraft, you'll see a little bit effect on the altimeter. It will, whenever that pressure wave goes through the static ports, then you'll have a little spike in the altimeter readout. But other than that, there's nothing special going on if the aircraft is well designed.
Okay.
So back in the days when they started it, they had the problem whenever the shock wave would move over the aircraft towards the control surfaces, that they might be having difficulties maintaining control. Mm-hmm. It also shifts, it shifts center of pressure and all that aerodynamics of the aircraft change in the transonics and the supersonic. And usually nowadays aircrafts are designed to allow a pilot to go through those areas without any undue handling issues. Back in the older days when we didn't have those experiences, actually was an issue. Then you could note it. I don't know if you've seen the movie The Right Stuff. It's a really good one from the 80s about the first astronauts and about Chuck Yeager and his first supersonic flight. And while it's a bit Hollywood-like, very dramatic and all that, basically that's what happened. They had a problem with a shockwave moving towards the towards the horizontal stabilizer. Mm-hmm. And when on his first attempts, he noted that at some point he wasn't able to control the aircraft anymore properly. They got around that with a trimmable horizontal stabilizer that at a certain speed range into the transonics, they changed, the angle of incidence of the horizontal stabilizer and got back control power. But it's all based on the experiences they made back in those days. Nowadays, in a modern aircraft, the flight control system will take care of those changes. You can still, if you go through the transonic region while maintaining high G, for example, you can notice a transonic pitch up or transonic effects. You feel it in the aircraft, but that's only if you go through it in a dynamic way. Straight and level, accelerating supersonic, nothing happens.
What's the fastest you have flown?
My fastest Mach was 1.84.
1.84. Yeah. So are there a lot of jets? I mean, they could possibly go even faster, but you don't fly them that fast because you don't have to test them.
No, I mean, those numbers, especially those high Mach numbers, in the end, they're bit of something for the books and if you sell an aircraft and saying, hey, my aircraft is doing Mach 2+, then at some point you have to prove it. But the operational relevance of those high Mach numbers in the airplanes I fly, like the Typhoon, a Tornado, is not there. Because, well, yes, you're very fast, but you're not really maneuverable anymore, and you use a lot of gas doing that. So you're always an afterburner, burning a lot of fuel. And there's no real operational use for those very high Mach numbers. So in those regions, 1.2, 1.3, 1.4, there is quite good operational use and operational relevance. And so the aircraft itself is also designed to be able to operate there well. But the high Mach numbers are just for the books.
Just for the books.
So, and there are other aircraft, obviously, that can fly faster. But then it's maybe their specific design. So I don't know if you know the SR-71 Blackbird, an old design back from the 60s even. So their task was to do high-level reconnaissance over Soviet Union, and they needed to be, in an ideal case, not interceptable by any aircraft or missile system. So they flew very high and very fast just to, get away as quickly as possible. So for them, it was important. And they were designed in a way such that at those high Mach numbers, aircraft control was still possible. Engines were designed specifically for that. They even had a specific fuel that they refuel in the air once they start doing the high altitude, high speed flying. But that's only because their operational requirement was fly high and fast. For any other aircraft, there's no value.
Makes sense. And one last question about like your experience. We asked ourselves, did you ever had to use the ejection seat?
No, fortunately not. But actually, I do owe my life to Martin Baker, who's the producer of the ejection seats, because my dad had to. He ejected out of the Starfighter in 76. I was born in 77. So actually, I do owe my life to Martin Baker. But me, myself, no, I haven't used it yet. I'm not planning to either.
Yeah, I can imagine, because there are a lot of G's like working on your body. And does your dad, I mean, it's a personal question, does he still feel it? Like when he had to use it? Does he still have some back pain from it?
No back pain. Funny thing though, during the ejection, due to those high G forces, the Bandscheiben, I don't know what it's called, those little wobbly things between in your spine, there's air in those. And during the ejection, that air is being pressed outwards. So after the ejection, he was 4 centimeters smaller than before it. And some of it got back, but he lost 2 centimeters in height due to the ejection. So
for good.
Yeah, for good.
Oh my God.
Yeah.
That's crazy.
That's crazy.
We were already talking about how dangerous or what risks there are. But what is more dangerous in your opinion? Working for the military as a pilot or working as a test pilot? I mean, because as a military pilot, obviously, if you fight in the jet, it's more dangerous. But most likely you won't. Did you fly any maneuvers with the military, like in a war zone?
No, I did go to war in Afghanistan, but on the ground. But I never flew there. In regards to the risk, well, obviously combat would be the riskiest thing about flying. But on the standard day-to-day flying routine, I'd still consider the military side with a higher potential for having an accident. Not risky, but a higher potential for an accident. Just because they are really operating the aircraft, well, at the maximum performance level every day, every single day. That's also what is the importance of my job, basically, is to make sure that the aircraft can be operated there and is safe to operate there, but they do it on a day-to-day basis. So the potential for something happening there, I think, is a lot greater than in flight test.
Okay, and I see you're wearing your engagement ring.
It's actually my wedding ring. So
your wedding. I'm sorry,
yeah,
that's not an engagement ring. Oh, my bad. But how does your family cope with you being a test pilot? Is there any influence by it?
No, my wife. I mean, I've been married for 21 years now, almost. When she got to know me, I already knew I'd be a pilot. Was already in the Airforce, and she sort of was prepared on what's coming. And we went through the United States training and all that together. So she's basically used to me going off to work in the morning and knowing that I'll be flying an aircraft or might be doing something that's maybe a bit riskier than a normal desk job. And we talk about it. Obviously, we've talked about it in the beginning. It's like, no, whatever you do, I think you can handle it, and she's fine. I think the more stressful part for the family during the Air Force time and also during my training to be a test pilot is a lot of absence. So in the Air Force, I usually, on average, was away 6 to 7 months a year in, like 2 weeks here, 3 weeks there. So a lot of away time from the family where basically my wife had to take care of everything. And then test pilot training was 1 year in England where she was at home with the kids. So I think that's more stressful than me going to work and going flying in the morning. So I think she's more scared I might have a car accident on the way to work than having an accident at work.
It's also more likely.
It is more likely, yes.
It is.
Yeah.
And one last thing about the moral. Is there any moral questions or any moral aspects you think about when you test fighter jets or even in the military? Mm-hmm. How do you think about that?
Well, I mean, obviously, when I was in the military, I had to ask myself the question before I joined, would I be willing to take lives or to sacrifice my life? And yes, I considered and thought about it. And fortunately, from my point of view, we live in a democracy, And it's not like, soldiers are being sent off to do some gruesome stuff and, kill people for no good reason. So whenever a reason came up for Germany to use military force, for example, in Afghanistan, was always based on a good judgment and on a political democratic decision, which basically for me rectifies the requirement to operate in the military world and maybe to have to take lives. And the other good thing is, especially in Germany, every soldier is a Staatsbürger in uniform. It's a citizen in uniform. And we are not only allowed to, but we are obliged by our oath to always also question orders that we receive. So it's based on our history in Germany. It's really the German armed forces are very, very keen on having soldiers that really questions the orders that they receive and really get into the whole, hey, is that democratically possible? Is that okay what we are doing? And we could refrain from, we could reject orders if they were not. Actually, we would be obliged to do so. So the moral question in the end is, would I be willing to take a life if I had to, or am I happy with, producing or helping producing weapons? I'd prefer if there weren't a requirement for weapon systems, for fighter jets, for guns, for bombs. But I mean, it's apparent that this is a wishful thinking. It's not a possibility. We're living, especially now, we're living in a world, in a time where even though we thought that, okay, peace is all around us, it is not. And there's always going to be that one bad guy or that one bad government, and you need to prevent them from taking steps that would harm a lot of people. And the only way to do that, from my point of view, is to be able to defend yourself and others.
Of course, that makes sense. So, and you mentioned earlier that you were at the Bundeswehr University of Munich. And when you were there, what were your routines? And what changed in your routines during the time you were there and afterwards as a fighter pilot?
Well, a good thing about the University of the Armed Forces is you go there as an officer, so you're being paid and you get, free housing, you live on a campus. It's very small Hörsäle, so very small classrooms, not a lot of people. You get to know the professors by name, and it's really intense. I mean, we studied in trimesters, which, it's compressed, but you don't have to worry about anything. That's nice. The thing also is you start, you're almost like a civilian. So once a week on Wednesday afternoons, you'd have your military afternoon where you put on a uniform and do some military training or something like that. Other than that, you're like a civilian. So for me, actually, I was probably like a lazy civilian student. To be honest, I was not very, back then I wasn't really interested. I wanted to fly. So going to university it just happened by pure luck that they chose me to go study before flying. It was really a privilege back then. And I didn't even want it. I was like, okay, I go to university. I didn't really enjoy it. I was lazy. Only until test pilot school, when I realized that all the stuff that I learned back then actually was useful for me, because I needed all of it again as a test pilot now. Back then I was a lazy student. So my daily routine would be getting up. Am I going to class now? Or might I maybe stay a little bit longer in bed? And I usually choose to stay in bed.
So you weren't obliged to do the classes?
No. Unfortunately not. Probably would have been a good thing if it had been mandatory. I'd probably have learned a lot more. Actually, I was fortunate. I was lucky as well. One of the professors, I think he's still here, Professor Hornung. I think he's still a professor here. And
we actually interviewed him as well.
Oh, right. Yeah. Perfect. So he was the one, taking care of me during my Diplomarbeit. And I was really lazy, and I don't know, the German saying is Gnade vor Recht ergehen lassen. So if it wouldn't have been for him, like closing both eyes and saying, okay, I'll let you pass with a 4.0, I probably wouldn't be here where I'm now. So why ever. I still don't know why he did it. I tried to get in touch here with him, but we never made the contact when I did some lectures for Matze Heller. But I don't know why he did it, but I'm really grateful that he let me pass through my degree, because otherwise I wouldn't be here today. And I think actually what back then I really lacked, the knowledge of how to work scientifically. I actually got to learn that now, and I think I'm a decent scientific pilot now. But it wouldn't have been for him. So if he's seeing this, thanks a lot, Professor Holland. I think you did a good thing there
to get you in touch.
So still on the topic of military and military environment, how challenging would you say is the military environment for a person?
Well, for person, it's challenging. I mean, you're there in a job where you might have to do the ultimate sacrifice your own life for someone else, for the greater good, if you will. So yeah, it's a demanding environment. For a military aviator, I think it's probably the most demanding job in aviation that you can be doing, because you're not only operating the aircraft, flying the aircraft is like getting you to your job, and your job is using the weapon system. And especially nowadays, there's a massive amount of information that is on hand for a pilot, but that he needs to use, that he needs to interpret, and that he needs to, make operational and tactical use of against other aircraft. And it's not like back in the days where it's one aircraft against the other, but now you have like 4, 6, 8, 20, 50 aircraft on your side, 50 on the other side. It needs to be orchestrated. It's a lot of coordination, and you need to have that situational awareness, SA, and you gain that from your systems and the information that's being provided. It's a massive amount of info. So it's probably one of the most demanding jobs I can imagine is a fighter pilot in a modern Air Force.
And would you say all the information you gain through, let's say, university or in general being in the military? I mean, I know this is maybe like a weird question, but how useful is it actually once you're in a situation where you have to use that knowledge?
I think I'm at a point where I might probably have too much information in on the scientific side of the flying. So, I'm a scientific pilot, if you will. I think the best pilots in the military have both. They have an analytical mind, but also they have a good gut feeling, which is based on their experiences, based on their knowledge, their training. But it sounds, it sounds a bit cheesy, but when you don't have time to think in air combat, and that's what really good pilots do. They act on their instinct, which is based on their knowledge and experience and training. So me doing a lot of more scientific type flying, thinking about something, why it happens, why it is in the background, I'd probably not be as good a fighter pilot anymore as I used to be when I was a bit less in depth involved.
Fair enough, yeah.
Yeah, of course, the future of aviation foresees the transition to autonomous vehicles, and you working on FCAS part of, what is your, not opinion, but what is the opportunity you see in autonomous vehicles?
I think in future conflicts, cooperation with autonomously operating vehicles is a must-have. It's the only way to basically be able to protect the force and the power that you need to be protecting in regards of numbers, sensors, and so on. And it's it's manned-unmanned teaming. Basically, what you want is one of the biggest cornerstones of the future combat air system. So it's not about an aircraft and a pilot, but it's about how to integrate an aircraft in a system of systems with remote carriers, with unmanned aerial vehicles as your sensors or as your weapon carriers, just to have force multipliers. And there's no way around it. The one thing I don't think is going to happen is full autonomy for military aircraft, just because it's well, first of all, it's politically not viable. It's nothing any politician would want, and I wouldn't want it either, to have systems on full autonomous operation. And the other thing is, and it sounds strange, but if you if you look at the movies again at Hollywood, if you look at something like Terminator and Skynet, if you will, I mean, we're at a tipping point from my point of view where it's very important to be restrictive what we allow artificial intelligence to become. Learning software is where we are right now in general terms, and software that develops and envelope and evolves. But I think now we're at the tipping point where we really need to make strict rules and be very conservative and careful in how much autonomy we allow our military systems or any other systems to achieve.
And so you already said that you wouldn't want no pilot to be on board and an AI, for example, like have all the power about the aircraft. But nowadays we already have the drones where you control them from the ground. Yeah. And do you think this is something that will be more in the future? And do you even will have some pilots on board on an aircraft in the future?
What I think you will have the force composition that you will be seeing a lot, at least on our side of the fence, if you will, and in a democratic way. You will have manned assets that cooperate with unmanned assets. It's the manned-unmanned teaming where we do a lot of testing already. Which basically means you have an aircraft with a pilot in command who is also in command of all kinds of different assets, so-called remote carriers, for example. So, for example, you'll have UAVs with you carrying sensors that can fly closer to a threat environment than you might want to be flying with your aircraft. You might have UAVs with you that carry weapons or that carry other things that you can use against an opponent. You can get closer to a threat than you might want to, but you still need to be there as human in the loop to make the final decisions for go or no go. So what basically I think the direction we're all taking is, yes, you'll have very autonomously operating aircraft without pilots or smaller aircraft, but they'll be operated task-based. So they will not be remote controlled because you cannot remote control 20 different aircraft at a time. But they will be task-based. And it's one of the biggest challenges, I think, in developing a system like this is how to get from a task that a pilot gives an unmanned aerial vehicle into, fulfilling that task in the best possible way. It's a very difficult feature, again, where we go into artificial intelligence and learning software because it's so complex of an environment.
So, but how you did explain it right now, I understood like the pilot is doing or controlling the UAVs next to him or that are surrounding him.
Yeah.
But he's doing this during flight, and how is it like the multitasking he has to do when flying and still controlling another
That's
vehicle?
what I mean by tasking other assets. So first of all, the flying in his fighter platform, his command platform, most of the time the flying will probably be done by the autopilot, allowing him to be more of a mission manager or system manager than a pilot himself. And then the tasking is really, so if he says he's in control of other unmanned aerial vehicles, he will not be telling them fly from A to B to C and then at D throw bomb on this target. But he will tell them,
makes sense,
in this area, identify any threats and destroy the threats. So this is task-based operation. And that's the biggest challenge, how to translate that task into something that an unmanned aerial vehicle can actually fulfill in a good way. And so he'll be the battle manager in his combat aircraft, managing what his additional assets are doing. And that's the autonomous part of it. They'll be doing based on his tasking, not his commands, but on his tasking.
What you're describing right now is almost already FCAS, or is it?
It is, yeah.
Yeah, actually on that topic. So for those who are unaware, maybe our listeners, FCAS stands for Future Combat Air System.
Yeah.
And it is a German, French, Spanish project.
Mm-hmm.
And the goal of this project is the development of a next generation weapon system, basically. And also different like technological assets when it comes to the battlefield. So could you maybe give us more insights into the topic, some more information about what the main goal of the project is.
I think, and you put it quite correctly. So the first misconception you usually stumble across when people talk about FCAS, they think it's an aircraft. It's not. It's really a system of system, which makes it a bit boring for me as a test pilot. But again, that's what the future will look like. So what the FCAS means is actually, as I said, it's going to be a command fighter as one entity, like the next generation fighter aircraft that's being developed right now, that will be commanding all kinds of assets, like remote carriers who carry sensors, radars, passive sensors that might be very low observability platforms, so they cannot be seen easily by radar. They might be able to get to points where you can't go with your aircraft, and you'll be managing those from your platform. But if you look at FCAS in its entity, it's not only that fighter and his remote carriers, wingmen, loyal wingmen. There's all kinds of different definitions and names, but it basically means a system of system, like today the Internet of Things, if you will. It's the same thing in a different way. If you now have your fridge and your light and your heating in your house communicating with each other, exchanging information, it's going to be the same in future combat air system. You have all kinds of sensor platforms, weapon systems, command structures, and they all need to find a common way to talk to each other and operate together with each other. And that's the biggest challenge in designing the future combat air system, is going to find that common, what we call a combat cloud, that common area where they all talk to each other and they can derive information from each other, not even by asking, but because the information is just there. And it's a very, very difficult task, a difficult feat. But it's also very interesting development from my point of view.
So you mentioned that, of course, there's different platforms that play a role in this, let's say, system. I can imagine they're all at different physical locations.
They might be.
They might be. So is there any specific range in which the system would be able to operate in? Or, I mean, let's say if I have one system here in Germany and the other system at the other side of the world, would that be feasible? Or
now, this is when we started up, I said there's no questions that can't be asked, but there might be questions that I may not answer to. So this is, this goes in direction of capabilities, foreseen capabilities that I just cannot discuss in public domain.
Okay, fair. Yeah.
So we're coming to an end, but we still have some concluding questions. First would be, what exciting projects are in your pipeline? Are you working on? Like, is there anything coming, or is it just things you do right now?
One of the exciting ones on the, say, legacy side is big upgrades coming for the Eurofighter on the avionics side as well as on the aerodynamic side. So they'll, as I talked about, the initial program that I did a couple of years ago, where we changed the aerodynamic shape of the aircraft and expand its envelope. So from a pilot's perspective, it's one of the exciting things to do, envelope expansion, flying a new type of aircraft or an aircraft that hasn't been flown like that before. And then obviously part of FCAS is the next generation fighter. So currently we're in the design phase for the next generation fighter demonstrator. It's a demonstrator aircraft that's being built before. First flight is foreseen somewhere probably 2028-ish, around that area, which I'm also the project pilot for on the German side. And obviously, for a test pilot, it's the most exciting thing that can happen is to be one of the first people to fly a new aircraft and being part of the development and even being able to, giving inputs into the design, into the flight control system design, into cockpit design, into HMI, and then being able to do something no one else has done before. It doesn't get better than that.
Fair enough.
It doesn't really. And it's interesting as well, because now you work with the French, with Dassault, you work with the Spanish side, and the interesting thing is there's different mindsets. And you've heard about, there's lots of discussions and even, some fighting going on the political, strategical level. When you get down to the working level, when you start working with the engineers, or when I talk to my fellow test pilots in France or the fellow test pilots in Spain, it's really, we all want the same. We want to develop a new system, a new aircraft, a new demonstrator aircraft, and it's an exciting thing. It's the best thing you can do as an engineer as well, for the engineers, being allowed to get all their new ideas into a demonstrator aircraft and being on the forefront of development. For me, it's a good thing because the cool thing, I'll be flying it. For them, it's, they're developing something completely new. I think there's a lot of pride and a lot of cooperation going on the working level. So whenever you hear about maybe the fighting going on between, the leaderships of the companies,
politics.
It's politics, it's strategy, and that it's normal, and it needs to be like that. But on the working level, it's great to experience how, people from different countries have the same mindset, the same ideas, the same goal, and the same, the same happiness. I'm looking for the English word, Leidenschaft, passion, the same passion for something. And that's also a great part of it. It's not only the flying it, but, getting together and being part of something new it's what makes the job.
Yeah. And the last question we usually ask our guests is, what advice would you give to young students who want to follow your path? I mean, obviously, most aerospace engineers won't be like, oh, I want to go to the Air Force right now and start as a test pilot, or want to become a pilot at all. But you, like you always said, you work with the engineers together, and maybe you can give some advice on that part of the job.
I think I wouldn't want to give technical advice, but I think it's always like it was for me. I was 6 years old, stepping in an aircraft, and I'll be a pilot. I was like, yeah, I'll be a pilot. It was a dream. So it was that's what I wanted. And I just did everything to get there. And I got lucky in very many instances becoming a test pilot. I was really lucky to be at the right time, at the right place, with the right experience. But if there's one thing I'd tell you, it's all about attitude. It's about your own attitude, how you approach what you want. You can dream and you can have a desire. If you dream, it's something like, yeah, it would be really cool to be a pilot. It would be really cool to be an engineer. And it's nice. You need to dream it. It's good. But if it's desire, it's something you want, then you have to work for it. Then you have to get down to business and say, okay, this is my desire. I want to become a pilot. I want to become a engineer in a big aircraft company. I want to do this or that, whatever it may be. It won't be there for free. It's not like people might have been telling you, you can achieve whatever you want. Yes, you can, but you'll have to work for it. And like it was for me, it's a dream job. It was a great experience. It was a lot of hard work as well. Like 6 days a week, 14, 18 hours a day, working for a year, 2 years at a time, just to get where I am. But it was worth every second of it. And if there's an advice I'd like to give you, don't stop dreaming. But if you have a desire, work for it, and you can get there. You just have to work hard.
We had a lot of fun, and we wish you all the best for your future project. And maybe some of us will see you again.
Yeah, hopefully. I mean, thanks a lot for having me. First of all, I really enjoy being here. I really enjoy being at the university, talking to young people, and with the same passion that I have, with a shared passion. And it would be great to see you. And let me take out the invitation. So if you'd be interested, come visit me in Manching. We'll go take a look at our facilities, take a look at flight tests, take a look at our simulators. And if in the end one of you says, hey, I really now have the desire to get there, and you start working hard, that's all I can hope for. So it is an honest and earnest invitation. Come visit.
We gladly accept the invitation. I mean, at least
wonderful.
I do. I don't know about you guys, but I do. For sure.
I won't have flight suits for you, but no, honestly, I really, and that's a good thing. I enjoy sharing my passion. I enjoy sharing what we do there. And it's one of the benefits that I have being a test pilot. People tend to listen to me every once in a while, and I try to, not misuse that. And if I can, give something back of that, what I've gotten, then I gladly do that.
Honestly, it was an amazing talk.
Thank you so much for the chat. It was really nice.